Okay, in Chapter 11, we are going to take a look at the drill problems, and remember that the problems are algorithmic, and therefore they change as you go from one problem to the next as they're populated in Connect. And also this may be a different version of your textbook, so we're using the values that I have in front of me right now. And numbers 1 and 2, we're looking for the bank discount and the proceeds, which are steps 3 and 4 in the discounting process. Okay, then numbers 3 and 4, we're looking for the discount period, which is step 2 in the discounting process. And then numbers 5 and 6, we're looking for steps 1, 2, 3, and 4, which is a maturity value, discount period, the bank discount amount, and the proceeds. Okay, so let's go back and look at numbers 1 and 2. Number 1 is we're changing the symbol. It looks like interest is equal to principal times the rate times the time, which I use as IPERT, but now we're going to be McDLT without the lettuce, B up here in the interest area, M for the maturity value, D for the bank discount rate, and then T. I'm going to be McDLT without the lettuce. So therefore the maturity value on this first one is $42.50, and the bank discount rate is 2.5% or 2.5, and after you move the decimal point 2 places to the left, it's 0.025. And then the time is for 190 days, and this particular problem is discounted based upon the ordinary interest method, so it's a 360-day year. So we need to calculate for the bank discount amount. So $42.50 times 0.025 times 190 divided by 360 is equal to a bank charge or bank discount rate of amount rather is $56.08. And with the simple discount notes, instead of adding this to the principal to give you the maturity value, we're going to subtract it from the maturity value, and therefore the rate really truly is not 2.5%. It's actually going to be a little bit higher for the real effective rate. So this particular problem right here, to get the proceeds, we are going to subtract the bank amount of $56.08 from the maturity value, and so the proceeds will actually equal $4,193.92. Okay, let's go ahead and look at the next one. Okay, we're going to be a McDLT without the lettuce, and the maturity value is $2,900, and the bank discount rate is 6.25% or 6.25, and move that decimal point 2 places to the left to make it 0.0625, and then the time is for 180 days over 360. So we're going to calculate for the bank charge, and 2,900 times 0.0625 times 180 divided by 360 equals a bank charge of $90.63. Okay, I am going to subtract the maturity value. I'm going to subtract the bank charge of $90.63. That's the bank charge. I'm going to subtract that from the maturity value to give us the proceeds of $2,809.37. Okay, our rate is 6.25%. Actually, the effective rate or the real rate is a little bit higher than that. How do you know? Well, we're subtracting out the bank charge immediately and then giving the proceeds immediately to the one who originated the note. So therefore the effective rate is not 6.25%. The true rate is always just a little bit higher. Well, the rate is equal to the interest or the bank charge divided by the proceeds. I'll put that PR instead of P for principal. The proceeds times the time. So the interest is $90.63 divided by the proceeds of $2809.37 times the time of 180 divided by 360. Okay, so therefore, let's go ahead and scoot that over to 9063 divided by, now let's calculate the bottom. So I'm going to clear my calculator, enter 2809.37 times 180 divided by 360, and that equals 1404.685. Now I'm going to clear the calculator. 90.63 divided by 1404.685, and that equals 0.0645 or 6.45% after you move the decimal point 2 places to the right. So the real effective rate, which this question was not asking, I just want to show you that the effective rate is actually a little bit higher than the stated rate of 6.25. Okay, now let's go ahead and move on down to numbers 3 and 4. Okay, we're going to base numbers 3 and 4 upon step 2, the discount period. So if you have April the 12th as the date that the loan originated, and it ran for 45 days. We need to find the date that it matures because I don't know that. So I've got to calculate for that. So April the 12th plus 45 days gives me April the 57th. Okay, April 57th doesn't exist, so I'm going to subtract out 30 days in April to give me 27 days in May. So May 27th is the maturity date. So I'm going to go ahead and plug that in over here, May 27th. Okay, now I find that the note is discounted on May the 2nd. Well, the difference between May 2nd and May 27th, this is an easy one to calculate. It's only 25 days. So that's the discount period. Now move on to number 4. And the note originated on March the 7th. And it goes for 120 days. I don't know what the maturity date is, but I'm going to find that out. So I'm going to start right here with March the 7th plus 120 equals March the 127th day. Okay, that doesn't exist, so I'm going to subtract out 31 days from March to give us 96 days in April. Subtract out 30 days in April to give 66 days in May. Then subtract out 31 days in May to give us 35 days in June. Subtract out 30 days in June to give us 5 days in July. Okay, so July the 5th is the maturity date. Okay, now I'm going to discount this note on June the 8th. So the number of days between June the 8th and July the 5th, first of all, June the 8th, there's 30 days in June, so that means that there are 22 days remaining in June. And then July, it matures on the 5th. Add that together. That means there's 27 days in the discount period. Okay, let's go ahead and take a look at the full problem. We're going to solve for steps 1, 2, 3, and 4. Okay. Here we go, right here. Number 5, the principal is $50,000. And we'll solve for the maturity value, the discount period, the bank discount, and the proceeds. Assume that numbers 5 and 6 have a bank discount rate of 9% interest. Okay, we'll start with number 5 with $50,000 at 11% interest. It's a 95-day note, and the note is dated originating on June the 10th, and it gets discounted on July the 18th. Okay, so let's go ahead and take a look at all of those 4 steps. And I'm going to divide this up into columns. So this is step 1, and this is equal to the maturity value. There's 4 steps: maturity value, the number of days in the bank discount period, and then the step 3 is based upon finding what the bank charge is going to be, the bank discount amount, and then finally what they're going to give to the person who originated the note after they had it discounted. That's called the proceeds in step 4. So step 1, and we're going to start with IPRT. So this is back to chapter 10 for step 1. It's calculating for simple interest and then adding the interest to the principal to give us the maturity value. So it's a $50,000 note, and the rate is 11% or 0.11, and then the time is for 95 days over 360 since it's ordinary interest. Okay, so that's going to give us $1,451.39 for interest. Maturity value is equal to principal plus interest. So the maturity value is equal to $50,000 plus $1,451.39. That'll give us $51,451.39. So there's the maturity value right there. Step 1, $51,451.39. Okay, now step 2. This is the discount period. So in the discount period, I know that the note originated on June the 10th. Okay, this particular note, the length is 95 days. So I don't know the maturity date right now, but I'm going to calculate it. I'm going to start with June the 10th plus 95 days, and that's going to give me June the 105th day. Okay, I'm going to subtract 30 days from June to give me 75 days in July. I'm going to subtract 31 days in July to give me 44 days in August. I'm going to subtract 31 days in August to give me 13 days in September. So September the 13th is the date that the note matures. Okay, now we're going to discount this note on July the 18th. We need to find the number of days between July the 18th and September the 13th. Okay, to do this, I know that July the 18th has 31 days in it. So that means that July has 13 days remaining in it. Okay, 13 days remaining in July. And then August has 31 days. And then September, the note matures on the 13th. So that equals 57 days. So there's 57 days in the discount period. Okay, now for the third step, we're going to find the bank charge. How much will the bank charge us, or the bank charge amount, for discounting this particular note? So therefore, I'm going to change the symbol here and change it to B, make D LT without the lettuce. So the bank charge is where the interest usually is in Chapter 10, and then the maturity value is where the principal usually is in Chapter 10, and then the bank discount rate is where the original rate is in Chapter 10, and then the time is the bank discount period time from Chapter 10. So I want to go back to the first step, and my maturity value is $51,451.39. Oops, 451. 451.39. And the bank discount rate is 9%, which is 0.09 after you move the decimal point 2 places left. And then the bank discount period is 57 days over 360. And then after we calculate this one, $51,451.39 times 0.09 times 57 divided by 360. That's going to give us a bank amount of $733.18. Okay, then in step 4, we're going to calculate for the proceeds. Okay, all we're going to do here is we're going to subtract the bank charge from the maturity value. I'm going to put BC for bank charge, subtracting it from the maturity value of $51,451.39. The leftover is the proceeds, and the proceeds would be $50,718.21. Okay, so you have your 4 steps. First, you calculated for your maturity value, which came up to $51,451.39. Then your discount period that the bank had it discounted for 57 days. And then they charged $733.18 and subtracted that out immediately from the maturity value to give you your proceeds of $50,718.21. Okay, let's do this one more time. Then we'll go to the summary practice test. Okay, so number 6. Again, this is step 1. And this is a maturity value. And we'll start with Chapter 10's IPERT. Interest is equal to principal times the rate times the time. And our principal is $25,000, the amount that we're originally going to borrow. And the rate is at 9%. And the time is for 60 days over 360 days. To find the interest, multiply principal times rate times time, 25,000 times 0.09 times 60 divided by 360, and then that will give you interest of $375. The maturity value is equal to the principal plus your interest. So the maturity value is 25,000 plus 375 to give you $25,375. Okay, then step 2 is the discount period. So we originate the note on this one on June the 8th. And this runs for 60 days. To calculate for the maturity date, I'm going to take June the 8th plus 60 days equals June the 68th. Subtract out 30 days in June to give me 38 days in July. Subtract out 31 days in July to give me 7 days in August. So August the 7th is the maturity date. Okay, then we know that this note is being discounted on July the 10th. Okay, we need to calculate for the number of days between July the 10th and August the 7th. There's 31 days in July, which means that there's 21 days remaining in July. And then August, it matures on the 7th, so that gives us 28 days in the discount period. That brings us to step 3. And this is the bank charge, or the bank amount. We're going to change the symbol altogether on this one. And will be a McD LT without the lettuce. And the bank charge is up there where the interest usually is in Chapter 10. The maturity value is where the principal is in Chapter 10. And we'll use a bank discount rate. And this one's 9%, which is going to match what it was also in Chapter 10 on this one. And then the amount of time that the note was discounted by the bank will be represented over here in the time. So the maturity value is $25,375. Okay, the bank discount rate also happens to be the same as it was for the finding the simple interest of 9%. And then the time is the number of days represented in step 2, which is 28 days over 360 for ordinary interest. And therefore, $25,375 times 0.09 times 28 divided by 360 is equal to 177.63. Okay, that's the bank amount right there, the bank charge. We're going to go to step 4 now. And step 4 is the proceeds. We are going to subtract the bank amount of $177.63. It's a bank charge for BC. And we'll subtract that from the maturity value of $25,375. And the proceeds will equal $25,197.37. Okay, steps 1, 2, 3, and 4. Finally, on number 7, calculate the effective rate of interest to the nearest 100th percent for the following treasury bill, given $10,000, the Treasury bill at 4% for 13 weeks. Okay, so this is a B, MACD, LT. And this is $10,000 for the maturity value, and 4% or 0.04 for the bank discount rate, and the number of weeks is 13 out of 52 weeks. So 10,000 times 0.04 times 13 divided by 52 gives us $100. So we're going to subtract out the bank charge of $100 from the $10,000. So the proceeds will be $9,900. Okay. The rate is equal to the interest or the bank charge divided by the proceeds times the time. So the interest is $100, or the bank charge, the proceeds is $9,900 times the time of 13 over 52. So that's 100 over, and then we calculate 9,900 times 13 divided by 50. Whoops, put in the wrong number there. 9,900 times 13 divided by 52 equals 3.25. Now clear the calculator, and 100 divided by 3.25, that equals, oh, that's the wrong number. Okay, my calculator must not be working here. Let me try this again. 9,900 times 13 divided by 52 equals, okay, this is where I fell apart right here. The answer is 2475. Okay. Then 100 divided by 2475 is equal to 0.040404. Move the decimal point 2 places to the right, which is 4.04%. So the effective rate is slightly higher than that of the stated rate. Okay, the battery is about to run down on this one, but the same types of problems apply to the summary practice test, and also the summary practice test does have a video associated with it from the publisher that's located in the e-version of your textbook, so you can watch the video associated with that. And usually I do apply the summary practice test to each one of these, but since the battery is dead and I'm in a remote location, please go ahead and view the video associated with the summary practice test. This concludes Chapter 11.